Hello and welcome back to my channel. Today in this video we are going to discuss Cambridge A-Level Mathematics 9709, and it is Pure Mathematics 2-3, which is basically Pure Mathematics 3. And in this video we are going to discuss the topic exponentials and logarithmic functions. And after the topics, completing all the topics, we will see some questions which from the past papers. So let's start with the topic. So before the topic, let's see what we are going to discuss in this chapter. We'll understand the relationship between the logarithms and indices and use the laws of logarithms, and then understand the definition and properties of exponential e to the power x, ln x, including their relationship as the inverse function and their graphs. Use logarithms to solve equations and inequalities. Once we are done with the laws, properties and all definitions, so we will solve the equations and inequalities in which the unknown appears in indices. And the final thing we will discuss is logarithms to transform a given relationship to a linear form, and once it is linear form, we will determine unknown constants by considering the gradient and or y-intercept. So here's the first topic, which is exponential function, the definition. Exponential function, any function of the type a into r to the power t, where t is of course a variable, a and r are the real number. And variable, it says t is real number. Of course variable means t would be real number itself. It's like when we write f of x, so x is the independent variable and then fx is the dependent variable. So any function of the type, let's say fx equals 2 times, let's say 5 or 3 to the power x, this type of function we call it as exponential function. And there would be two cases. One is exponential growth, when this base, we can call it as base, when our base r is greater than 1, we will get the exponential growth, and when r is less than 1, this is going to be exponential decay. And in both the cases we can see the x-axis is the asymptote, because they are not going to meet this axis, or we can say they are going to meet this x-axis at infinity. And when r is 1, of course we will get a constant function, let's say f of x equals 3, 5, 7, something like that. So it is going to be a straight line, horizontal line. Next is logarithmic function. So logarithmic function basically is the inverse of the exponential function. So it means we are going to remember the logarithmic function from the exponential function. So whenever we have y equals b to the power x, and in our variable, our unknown, let's say, is x, so if we need to find the value of x, we'll use the log, and then x is log of y base b. There is a need of this b base. We can see the base earlier also, y equals base b to the power x, and here x is log of y with base b. And here of course x is real number, y real number, but y has to be greater than 0. y is greater than 0, we can see it is not going to be defined bit less than x less than 0. There is no function less than x is less than 0, or on x-axis less than 0, less than or equals to 0, there is no function defined. So if we have y equals b to the power x, its inverse means the reflection from the y equals x line. This is going to be the reflection of this. So y equals bx will give us y equals log of x base b, and here the x, the input would be, or domain would be, always greater than 0. So next let's discuss some basic properties of logarithm. First one is, I would say we need to remember these 4 properties. First one is log of 1 with any base is going to be 0. We can see from the graph, if we focus on this point, or let's say this point for that matter, here on y-axis x is 0, so y equals b to the power 0, that is going to be 1. And when we reflect it, this is also going to be 1. So at this place y is 0, so that's why when x is 1, input is 1, y is 0, log of 1 is going to be 0 with any base. Log of a base a is 1, log of a to the power x with base a is simply x. So we can remember whatever is there in the power will come in the multiplication, and then we can use the second property. Log a base a is 1, so it is going to be itself x. And a to the power log of x, a to the power log of x, the only thing is base has to be a, then we will simply write it as x. So we'll use it several times so that we can remember this in the question. Next, 4 logarithmic laws or 4 algebraic laws for log. When we find the log of product, it is the sum of the logs. Log of product is sum of the log. Yeah, there is a confusion sometimes where students use like log of x plus y is something like log of x plus log of y. This is wrong. It is log of xy is log of x plus y. So we can remember like log of product is sum of the log, and log of quotient is the difference of the log, numerator log minus denominator log. Log of x to the power n, n will come in the multiplication, power will come in the multiplication, and then we are left with log x. Log of 1 over x is minus log x, and we can see this is actually the use of second property. We can rewrite this thing as log of 1 minus log of x, and we have seen the property that log of 1 with any base is 0. So if this is 0, we are left with only minus of log x. So these are the 4 properties. So with the help of this property and these 4 algebraic laws, we are going to solve any question of the log. There is a new term like we have seen in the exponential function. The base was anything, any real number, or the only thing was like r can be greater than 1 or less than 1 or equals 1 also. But if we fix the base e, if we fix the base as e is 2.71828, it's a greater than 1, so we can see from the graph also that it is going to be exponential growth. So when we take base in any function as e, it is the exponential function e to the power x, and the inverse of this e to the power x is ln x. So ln x, ln is ln, we call it as natural logarithms. Ln is base e, so we can write either ln x or log x base e. So it's difficult sometimes, so it's easy to write ln x, and ln x is the inverse function of e to the power x. So what we got, if we have y equals b to the power x and we take the inverse, that is log of it, so it is going to be log of y base b here. But if it is e to the power x, then it is going to be simply ln of y, because the base is e. So let's solve some equations and inequalities after using these having these properties, I mean. So first one is, if we have 4 to the power x equals 16, by taking log we are going to solve. Otherwise also by using a very simple logic, 16 is 4 to the power 2 and here 4 to the power x, comparing them we will get x equals 2. But we are going to solve by log, because in the questions we will never get this easy. So taking the log both the sides, we can take the log both the sides, so we will get log of this equals log of this, and the first we can see the property, power will come in the multiplication, so x log 4 become log 16, and from here x we will get log of 16 over log of 4, which is 2. We can check it from calculator as well. And the equation is sort of easy, but when it comes to inequalities there are some concepts we should know. First one, when it is 5 to the power x is less than 13.3, we can always take log or ln for that matter. It hardly matters which you are taking. Log is going to be, then we are going to take the log both the side, we'll get this. And since the graph, if we see the graph of log is like this, so it's a monotonic function. Monotonic function means if we choose any two values of x, let's say this x, So corresponding y value will be also following the same inequality. Means if you see this x1 is less than this x2, so the corresponding y value is also less than corresponding y value of x2. So if this is less than 5 to the power x is less than 13.3, so log of this will also be less than log of this. So again the property x will come in the multiplication, log of 5, so we send it other side, we got it from calculator, and hence we got the set of values of x for which 5 to the power x is less than or equals to 13.3. But when it comes to base with less than 1, 0.4 to the power x is less than 0.0001. So in this case again we are going to take log. We'll get this step without changing the inequality, and we know, suppose we have to solve, let's say minus 2x is less than 1 and we need to find the x, so x would be greater than 1 upon minus 2 because we are dividing by negative number, or we can say multiplying by negative number. So when we multiply or divide by negative number, inequality changes. So here it was less than, but when we find x value we have to transfer this log of 0.4, which is of course less than 0. So it would be x greater than this value, and this value will get it from calculator. So we got the set of values of x. Lastly, we have to use the logarithms to reduce equations to a linear form. Equation to a linear form. Linear form means it has to be something like y equals mx plus c. Here it's not necessary always that we will get x and y. X and y, x is the independent variable, y is the dependent variable. So we can say x is, let's say, x square, that's also fine. We can take y as, let's say, ln y, that's also fine. This is a variable, but it has to be in this form. So what we are going to do, there would be two cases. One is exponential growth or decay, so it would be of this form. We'll take the log. We can use the property, there is a product and the power, so product means sum, and then power was coming down to the multiplication, so log y become this. And now if we compare, we got y equals m, this is m, and t is the variable, so mx plus c, this is a constant. So what we got, if we draw the graph of log y against t, then we'll get the intercept as log a and gradient as log b. Secondly, power law. When we have y equals a to the power a into x to the power n, again we take log, we got log y power 1, log a, n, log x. Variables are log x and log y, their power are 1, so we can say it is a linear form. And now in this case, if we draw the graph of log y against log x, log y against log x, we'll get the y-intercept as log a and gradient as n. So that's all from the topics. Now we are going to discuss some questions related to this topic. So here's the first question. Find the set of values of x for which 2 into 3 to the power 1 minus 2x is less than 5 to the power x. Give your answer in simplified exact form. So we are going to give our answer in the exact form here. And exact form means we are not going to find the value from the calculator. That's it. If it is log, let it be log. If we can simplify the logarithm forms, that's also fine from by the properties we have in our syllabus. Otherwise we can give our answer, we can leave our answer in that form itself. So here there are two graphs we can see. First one is 2 into this and second one is 5 to the power x. So second graph is the exponential growth, we can see, because base is greater than 1. And second graph, if you feel like it is a growth, so it is not, because this is minus 2x, the power is minus 2x. So if we make the power positive, then it would be 1 upon 3. So it is going to be a decay. So how do we solve for it? Of course we have two terms, one is in the left, one is in the right. So we are going to take the log directly. So taking log both the side, I will take ln both the side. So it is ln of 2 into 3 power 1 minus 2x bracket and then less than ln of 5 to the power x. So left side there is a property, product will distribute over addition, so it is ln of 2 plus, and the power I will write once, 3 to the power 1 minus 2x less than, power will come down in the multiplication, so again once more time this, and then this will come down 1 minus 2x into ln of 3 less than x ln of 5. We need to find the values of x, so we will collect the x together. We can see one x is here, another x is here, so I am going to transfer this x to the right hand side. So it is ln of 2 plus ln 3 into 1 is ln 3, and then it is going to be minus 2x ln 3, other side it would be plus 2x ln 3 plus x ln 5, the previous one, and then taking x common here we will left with 2 ln 3 plus ln 5. Ln means natural log. Left hand side we get sum, so we can use the property, and then 2 into 3 is 6 less than x, again this 2 is in the multiplication, we can send it into power, so it is 3 squared, that is 9, and plus, so it is multiplication, so 9 into 5, 45. So we got ln of 45. So for the set of values of x, we will transfer ln 45 to the other side. We are left with ln 6 over ln 45. We can either write our answer in this way, or we can write x greater than ln 6 over ln 45. Since they have asked for the exact form, so we are going to give our answer in this form only. Let's have a look at it, what they have asked from the graph, so that we can see how we have found the exact value and the equivalent decimal value as well from the graph. Let's see. So let's say this is the first function, and this is y equals 5 to the power x. Second equation, of course I told you it is going to be just a second, this is going to be exponential decay, it's coming down, 2 into 3 to the power 1 minus 2x, and we can see like which one we had to get the greater than 5 to the power x. So if we see these two line, vertical line, any vertical random line we can see here. So for the first line we can see red line is above, so it is 5 to the power x is less than, so we need to see the intersection point. If we find this intersection point, and it is 0.4707, and I have calculated ln 6 over ln 45 as well. So this particular point is ln 6 over ln 45. So any value of x greater than this value, we will see that it is going to be 5 to the power x is above the red line. So that's the set of values of x. So now here is the second question we are going to discuss. The variables x and y satisfy the equation this, where a and k are constants. The graph of ln y against x is a straight line passing through this point as shown in the diagram. Find the values of a and k correct to 2 decimal places. We can see the given equation is not a linear equation, but when we draw the graph of ln y against x, it's a linear equation. We can see it's a straight line. So our first task has to be converting this non-linear equation into the linear form, reducing this into the linear form, the last topic, and then we will use the logic of gradient and intercept. So let's have a look how to do. It is y square equals a into e to the power kx. Since the power is in the variable is in the indices, we can take the log. So taking ln, I'm taking ln both the side because they have also given ln. So taking ln both the side, we are left with ln y square equals ln a e to the power kx. I'm writing it once, but we can write directly the second step, which I'm going to write. power will come in the multiplication, so you are left with 2 times ln y equals, now it is product as well as power, so two properties together, it is going to be ln of a plus kx ln of e. And we know ln of e is 1 because ln means log base e, so log e base e is 1. So we are left with here as 2 ln y equals ln a plus kx only. Now we have 2 points, and remember the graph, this is the graph against of ln y against x, so any point if you choose on the this plane, it would be of the type x comma ln y. So it means this is the x value, this is the ln y value. This is the very common mistake actually, if you see read the examiner report students are committing. So if we substitute the first value, we get ln y is 1.2, so it is 2 into 1.2 equals ln a plus k times x. X is 1.5, so we are left with 1.5x. This is the first equation. Secondly, it is going to be this point, y is not y here, it is ln y, so it is 2 times 2.7 equals ln a plus x value is 5.24, and then it is 5.24x. Sorry, it is not x here, it is k. I wrote it before x, so that's why it happened. This is k, this is also 4 times k, because x value we have substituted already. Now it's now we can simplify a little bit more so that we can see the linear equation directly. It is 2.4 equals ln a plus 1.5k and 5.4 equals ln a plus 5.24k. Now it's a linear equation we are going to solve. I am going to subtract the first equation from the second equation. So 5.4 minus 2.4 is 3 equals ln a minus ln a is 0. 5.24 minus 1.5, 4 minus 0 is 4, 2 minus 5 is 7, and 4 minus 1 is 3, so 3.74k. So we got k value as 3 over 3.74. We'll write our answer till 2 decimal places, correct to 2 decimal places afterward. But before that, I'm going to use this value here in, let's say, the first equation here. So it is going to be 2.4 equals ln a plus 1.5 into 3 over 3.74. It does not matter how long you are going to write for the solution. We can write in less steps as well, but I'm writing like this, 3.74, and so from here we can get ln a equals 2.4 minus 4.5 over 3.74. Now I'm going to calculate this value directly from calculator. 2.4 minus 4.5 divided by 3.74, it is 1.19679, so I'll write 8. And then if it is ln and 8, ln a is given as a constant, ln a value is given already, so a value would be directly e to the power, the value there 1.1968, and from the calculator we can use the answer key for this, e to the power answer, because the last answer was 1.1968. So this value of a we are getting is 3.309 and all. Since we require 2 decimal places, so it is going to be 3.31. that is the value of a. And k value we can calculate 3 over 3.74, it is 0.802, so 0.802 0.80 because they have asked to correct to 2 decimal places. So that's the answer. Now here's the next question. Show that the equation this can be expressed as a quadratic equation in e to the power x. So whenever we have ln already included in the question, so we need to try it making like equation with only one term on the left hand side and only one term on the right hand side, so that we can use some property. So if I rewrite this thing as ln of 1 plus e to the power minus x equals minus 2x. Now we have only one term on the left hand side and only one term on the right hand side, and since we have ln of something equals to x, so we can directly use 1 plus e to the power minus x would be e to the power the thing we have on the right hand side. So we are going to take this negative power as the positive power, and of course we know how to do this because we are going to take it in the denominator. 1 over e to the power x equals 1 over e to the power 2x. Now we can, there are so many ways. I will simply multiply the whole equation by e to the power 2x. So we will get it as e to the power 2x plus e to the power x only, because 1 e to the power x would be cancelled by the law of indices, and here we are left with 1, and we can rewrite this thing as e to the power x to the power 2 plus e to the power x minus 1 equals 0, and this is quadratic equation in e to the power x. In the same question, in the B part, they have asked hence. So if it is hence, we are going to use the previous result. Hence solve the equation ln of 1 plus e to the power minus x plus 2x equals 0, giving you answer correct to 3 dp. So we have seen in the A part that this thing, the equation, can be written as e to the power x to the power 2 plus e to the power x minus 1 equals 0. And since we need to solve means we are going to find the value of or values of x. So first of all, since it is quadratic in e to the power x, we are going to solve by the quadratic formula. So e to the power x equals, by quadratic formula, minus b, so minus 1. Here we can see it is 1, so a in the quadratic, if we compare this thing, the whole thing as by quadratic equation ax square plus bx plus c equals 0, so that we can use the the formula. So b is 1, minus 1 plus minus square root of b square, that is 1, minus 4ac, so it is plus 4 over 2a, that is 2. So if we simplify, we are left with minus 1 plus minus root 5 over 2. So we'll get two values here. One is e to the power x equals, with plus sign, minus 1 plus root 5 over 2. Another is e equals minus 1 minus root 5 over 2. Sorry, it is e to the power x. And if we see the graph of exponential function e to the power x, the graph is this. There is no y value which is negative. So of course this particular thing is not possible. It can never be a negative number. So from here we will get x equals ln of the whole thing minus 1 plus root 5 over 2. And this value, actually we had to ignore the value which is not possible. So now we will get ln of minus 1, calculate minus 1 plus root 5 over 2. This ln value is minus 0.4812. So till 3 decimal places it is 0.418, and that's the value solution of this equation. Let's see another question now. In this question we are going to solve this equation and answer correct to 3 decimal places. Again it is same, and why it is easy, I would say, because in this case we can see that we have one term in left and one term in right. So if it is only one term, we can directly use the property. If it is let's say if it is e to the power x equals 5, then it is x equals ln 5, and in the similar way if it is ln x equals 5, so x become e to the power x, e to the power 5. So we can use them interchangeably very frequently, and we should be able to, because that would be easy to understand. Now we have ln here, and both the sides there are only one term, so we can directly write 1 plus e to the power minus 3x equals e to the power 2. And since there is only one x, so we'll transfer the rest of the things to the other side. So transferring the other side, we will get minus e to the power minus 3x equals e to the power 2 minus 1, and then minus 3x, again e to the power x we are left with now, so the power would be ln of e square minus 1. And since we require x value, so x become minus 1 by 3 ln e square minus 1, and this value we will get it from calculator. So this value is minus 0.618195, so on. Correct to 3 decimal places, we are left with minus 0.618 only. So now we have another type of question. Solve this equation where there are, we can see there are more than one term on one side, right hand side, and we need to give our answer correct to 3 decimal places again. So unless and until we make it either one term each side, or we solve by any other method, let's say quadratic equation or linear equation, so we cannot do anything here. We need to use some property so that we can make one term on each side. Left hand side we have one term, right hand side we have two terms, minus 1, and if we recall, we have log of a base a is 1, log of number with the same base is 1, and here in both the cases we have log 10 log 10, so we can write 1 as log of 10 to x plus 1 equals, and this 2 will go up as the power, so it is x plus 1 whole square, minus I am writing log 1 as minus log 10 base 10, and this is not the only way we should do. And then we will use the property, there is a minus, so minus means the original thing has to be division, so it is log of x plus 1 whole square divided by 10, and now we have log both the side. It's the same type like when we take the log both the side, then we can remove also log both the side, so we are left with 2x plus 1 equals x plus 1 whole square upon 10. I'm going to transfer this 10 this side, so it is 20x plus 10 equals x plus 1 whole square become x square plus 2x plus 1. Transferring to the other side, we are left with x square minus 18x plus 10 would be minus 10, so minus 9 and 9. So we are going to, of course we cannot factorize like this, so what we are going to do, we are going to use the quadratic formula, x equals minus b, so plus 18 plus minus square root of b square 324 plus minus 4 times, so minus 9 is there, so plus 9 into 4 is 36 over 2a, that is 2, and then we are left with two values of x, that is 18 plus 6 4 10 3 2 5 1 6 and 360 over 2, or 18 minus root 360 over 2, and then we'll write our answer from calculator directly. It is 18 plus root 360 over 2 is 9 plus 3 root 10, that is till 3 decimal place I'm writing 18.4868, that is 7, and when we take it minus, so it is minus 0. Till 3 decimal places 4868, that is 487. Till 3 decimal places, this is the answer. And it was not necessary to convert this 1 as the log 10 base 10. I'm giving you another solution here. We can simply transfer log to the one side. Let's say 1 to the left hand side and this log to the right hand side. We are going to get 1 equals log x plus 1 whole square minus log of 2x plus 1 base 10, and then we use the same property. We'll get 1 equals log of x plus 1 whole square upon 2x plus 1 base 10, and then since it is log and 1, so base is 10, it means x plus 1 whole square upon 2x plus 1 would be 10 to the power 1, that is 10 itself, and then we are left with we are going to get the same thing as we have seen here. So it's on us what comes in our mind first. We will start with that. So here's another question, and that would be the last question for example, as an example. So let's see how to do this type of question as well. Solve the equation 4 to the power x equals 3 plus 4 to the power minus x and give your answer correct to 3 decimal places. Again, we have 4 to the power x and 4 to the power minus x and plus 3, two terms, so we cannot take log directly. So let's first of all try to simplify, if we can simplify it easily. Minus x, we can write 4 to the power x equals 3 plus 1 over 4 to the power x, and then we have 4 to the power x in the denominator, so I will multiply 4 to the power x everywhere, so we'll get 4 to the power x square equals 3 into 4 to the power x plus 1, because 4 to the power x would be cancelled. And very common mistake is like students are multiplying 3 into 4. No, 3 is another term, 4 to the power x, 3 is the constant and 4 to the power x is a variable. We cannot multiply like that, we can leave it this way. And then we got a quadratic equation, so we cannot use log directly, we will use by the quadratic formula we have just seen in the previous part. So it is 4x to the power 2, or I will take this 4x as another variable, 4 to the power x as u. So our equation become u square minus 3u minus 1 equals 0, and then u equals by quadratic formula minus b plus 3 plus minus root minus b square, that is 9, minus 4ac plus 4 over 2a, that is 2. So we are left with 3 plus minus 9, 4, 13 over 2. So two values of u again, u is 3 plus root 13 over 2, and u equals 3 minus root 13 over 2. 3 minus root 13 is a negative number, I believe. Let's see. 3 minus root 13, from calculator it is negative 0.605. So again it is 4 to the power x, which is a exponential growth. It will never cross the x-axis, below x-axis it will never go, so it is not possible as it is less than 0. So only thing is this, so we'll write u again as in the original form, 4 to the power x equals 3 plus, let's see what is this value, 3 plus root 13 divided by 2. In this form it is 3.3027277, so I'll write 8 one more step, and then 4 to the power x equals this, use the log x equals ln, sorry, not ln, because here it is not e, so it is log of 3.3028 and base is 4. So we'll use this directly, log base 4, and answer here, and it is x equals 0.86183, 3 decimal places, it is going to be 2. And that's the solution, answer to the equation. I hope it makes some sense and it will be of some help. So let's meet again in some other topic. Till then, thank you so much.